Here's a quick recap for Monday, October 12th, and what we did in class today. The very first thing we did is we took some of our biggest loser discussion answers and we put them into a Google slideshow, and we had you work in individual groups to sort of analyze these particular statements. The statements that were chosen weren't necessarily wrong, but weren't necessarily right either. So each statement was a little bit different. Feel free to look at all of them if you want, but I'll show you what we did with these different statements. Let's take example number 2. When you lose weight, your body is turning fat into sweat. Somebody wrote this and somebody thinks this is what's happening when you do that. So if I take this and I'm going to go to my next slide, I'll show you what we were doing with that. You have an assigned statement, and that's the one I'm going to insert here. So I'll put that in there. When you lose weight, your body's turning fat into sweat. Do you agree? Well, you have to tell me whether or not you agree with this or disagree with this. And that's what you discussed in your breakout rooms. What's correct about it? What's incorrect about it? So you may have to analyze and look at the statement and see what do you think is correct and what is not correct. After we completed those two things, we went on to the next slide, which was, can we apply some of our knowledge to strengthen or help these people understand weight loss? One of the things we talked about was how important cellular respiration is. That process is actually converting one molecule into another molecule. Well, I did mention to a lot of groups that keep in mind that even though cellular respiration a lot of times pertains to glucose, which is then turned into carbon dioxide by the addition of oxygen. But keep in mind, we can also sub in other molecules for glucose, like fatty acids. Fatty acids could be substituted in because, again, they contain carbon, hydrogen, and oxygen also. CC and CH bonds that can be broken, providing us with energy for us to survive. So you don't always have to have glucose, but you can run off of some of those molecules in your body that your body is capable of breaking down. Well, where do these fatty acids come from? Fatty acids come from, obviously, the breakdown of fat inside your body. So if you have stored fat, you can get fatty acids, and then you can convert those into energy. So if I want to put that in here, so we can convert those into energy, plus obviously our CO2 plus our H2O. We can convert those fatty acids into that. And remember, you're always going to need oxygen to do that. So the fatty acids can be substituted for the glucose in that case. And so we can apply that to that knowledge there. Okay. Well, one of the things we also could help this person with is explaining how weight loss occurs with our big 3 questions. Are molecules moving? For sure, molecules are moving, because I know I could have fat stored in my abdomen. I could break that fat down, and we could go from the fat cell. And then from that, we can go to, I can copy and paste my symbol here. We can go from the fat cell. We could break that stuff down into fatty acids. And those fatty acids could go into the bloodstream. And that material could go to cells that need energy. So we can move these molecules around as we need them. Are these molecules changing? Well, sure, they're changing. So we know, for example, that the fatty acids, and we can just kind of copy what we have up here. We know that the fatty acids, if they go through cellular respiration, are going to be changing into CO2 and water. So we know that molecules are changing. And that site, remember, is going to be anywhere a cell needs energy. It could be a muscle cell. Well, that brings us to energy. How is energy transforming? Well, what do fatty acids contain? What kind of energy is that? Well, we know that that is chemical energy. And if we are using energy to move or something to that effect, oops, we don't want all that. We might be producing we're probably going to be producing what is called kinetic energy or motion energy. So that motion energy is what we're going to use to from the potential energy that was stored in the bonds of the fatty acids and things like that. So remember those CC and CH bonds. And we'll convert that potential energy into kinetic or motion energy. And that also is going to produce some heat energy too when we're doing that. So we got our energy all committed there. So we cover that in breakout rooms, and as a group, we should know and understand these things, which can help us with our assignment for today. And our assignment was under week 8, metabolism evaluation, in which we're going to use this reading here about food and what happens to it, just another simple reading to explain what's going on inside the cell. Now, you do need to draw small intestine cells with villi, and we have that as an example of what you need to do. And that needs to be inserted into your document. So we'll show you that. And here's an example of that. So we have our small intestine, and whatever's on the right side, by the way, is where our food is. We have our fiber, our protein, our water, our carbs, and we have some enzymes. And we know that this stuff has to be broken down and then absorbed into our blood. So what does it break down into? You can spruce up the drawing. I would say that this drawing is like 50% done, but what is it? What are the molecules breaking down into? That's going to need to be put in here, and it's need to be completed. Once you get that completed, you take a nice picture of your drawing, crop it, and then you insert it into your document, which is right here. You're going to replace this one with your picture. So you'll insert that in there. Once you've inserted your drawing that explains how food is broken down and gets into the blood, you can then answer the matter changing question, because this is all about matter moving. You can then get into the energy changing question, and then finally a short paragraph explaining how does a cow get smaller organic molecules to its cells. So how does it get molecules to its cells? Just a short paragraph on that, and then you'll have that one done. That's a recap for what we did today. Good luck. If you have questions, let me know. Peace.